So I realize this video does sound pretty crappy. I didn't have my headphones on at the time, so as long as my friends can lay off on the sound, I'm probably going to redo this video anyway. I just wanted to get it up there to see how my new Logitech camera worked. Probably noticed this is my first video where you can actually see me, so stay tuned, check out the rest of the video on intro to IP addressing and a little bit on routing. Create kind of a CCNA setup. So let me add some nodes. That's not what I want to do. Add a node. Cisco iOS on Linux. I'm going to start with, let's add the unlimited to 15.5.2. So just do this one. We have, let's just do 3 routers. Let's see, how many connections should we have? A single connection to a switch running trunks. And how about a single serial interface? That kind of make it a doubly attached kind of thing. So I'll have 1, 2, and 3. And then I'm going to add a node of Cisco IOL. This time I'm going to do layer 2, which I have 15.2D. Hopefully that's good. These are going to be switches, Ethernet ports, 1, 2, 3, 4, 5. So let's just do 2. Let's do 3 switches, same thing. This one, router 1, router 2, and router 3. We're going to connect these together. Serial 1, 0. Serial 1, 1. And I think serial 1, 0. Let's just do 1/2 to keep it simple. We're next going to do the same thing with our switches here. I know they look like routers, but just how they are. 0, 0. 0, 1 to 0, 1. 0, 2 to 0, 2. Kind of keep that consistent. Well, that's not good. Okay, and then we'll connect up router 1 to router 4. 0/2, 0/2. Now let's do 0/3, 0/3. Same thing here. 0/3 to 0/3. 0/3 to 0/3. We'll just make it kind of consistent here. So here's a weird, interesting little setup we can look at. So we can look at this topology in a couple of different ways. You see here that the routers are connected via serial interfaces, so we can kind of pretend those are T1s or DS3s. And then the connections internally can be pretty much anything we want. It could be VPLS, MPLS, it could be internet-based. Of course, if it was internet-based, I probably should have added routers in between to act as kind of an ISP, but for now we'll just do it as kind of a VPLS connection. So I'm not going to configure the internal switches yet, so to speak. Let me see here. Let me also connect E1/0 and E1/0. E2/0, 1/1 to 1/1, and 1/2 to 1/2. This will enable us the ability to see port channeling pretty much on top of everything else we're looking at. So what we're going to do is we're going to start up these devices. Hopefully these will be good and all done. Now 100.30 down here at the bottom. You see here at the bottom of the screen, it might be this side, that we have 100.30, 897, 900, 901, 902, 98, 99. So 897 to 902. So let me get my guess I don't have secure CRT on here yet. How about on my Windows 7 box? Nope. So we'll just use PuTTY. Anyway, these are all telnet connections. So 192.168.100.30 telnet 32.897. Get my telnet here, 192.168.100.30, 32.897. We'll make sure it's a telnet connection. Open up over here in a different screen. You see here we're connected to a network device, in this case R1. So we'll also connect up to 900 really quick. Telnet. And you'll see here that this takes us into the switch. Switch 4. Switch 4, switch 5, switch 6, blah, blah, blah. So you'll see here we're connected to a router and a switch. Now we have to use the enable command to actually get in to do more show commands. So from here, let's do show interface descriptions. You realize that they're all admin down right now. So what we're going to do is look at our router and switch, E0/3. So we have to go into configure terminal, which gets us into the configuration of the right portion. And we'll do interface Ethernet 0/3, no shut. Now if you want to do a command like show interfaces description, you can't do it from here. You have to either exit all the way back up, or you can do end, or you can do the do. In other platforms they have the same type of thing, like in Juniper they have run, Cisco they have do. So do show interfaces description. Now you see here that Ethernet 0/3 is up. Do show CDP neighbors. Nothing there yet. So same thing on the switch. We use enable to get in. Show interface descriptions. They're all up. E0/3 is up. Show run interface Ethernet 0/3. Nothing's configured on it. Do show run interface Ethernet 0/3. Nothing there. Do show CDP status. Let's try neighbor. Ah, there you go, and the switch shows up. As you can see here, local interface E0/3 is connected to the switch on port E0/3. So from here, let's exit out, do a host name R1, You'll see here that the host name has now changed, and we have to do write. It's technically just write, but more technically it's write memory. Basically the equivalent to copy the running config to the startup config, which then you can choose the destination file. Do the same thing over on switch 4. Show CDP neighbors. You'll see here that I'm actually connected to all the other switches and the router, of course. You're also going to see here that we have R1 because we just changed the name. You're going to see this router here under the device ID until the hold time expires, which in this case is about 180 seconds. Show CDP neighbors again. Shows us switch. And it should give us SW4 eventually. There you go, switch 4. It takes a little while to come up on some of these Linux platforms. You see here now that we have a connection to switch 4, but we're not going to be able to get through the network until we do a couple more things. So, if you remember before, 897 was router 1. So we got to come in here and do 32.898. Telnet, open, opens up in another window here. We do not want to use the initial configuration, which I will go through at some point. Let's also do the same thing to R3. Telnet, open. Now keep in mind, whenever you're consoling into a device, in this case it's technically a console, you're telnetting to the console, you have to hit the escape button for it to work. In this case, by default, it's enter, and this gets us into the device. So once we get into these devices, we can change the host names to R2, and of course, R3. Once that's done, we'll have R1, R2, and R3 ready to be configured. There's one other thing you need to realize when dealing with routers. If you forgot, we need to make sure to go into the interface, do the no shutdown command. Because if you don't, it's technically going to be in the admin down. So interface E0/3, no shut. We can just do a WR, do write if we're in config mode. Now we should have all of the systems at least up and running. Doesn't seem so yet. Once again, problem with IOL. Just need to show a little restraint and a little bit of patience because it takes a little while, of course. So show CDP neighbors, and there you finally see switch, which of course R2 is connected to switch 5, R3 is connected to switch 6. Those are just default names that you get with Eve. Now, when you want to start out talking about how to communicate on a network, you have to go into a little bit of IP addressing, which can be pretty math intensive. In this case, we all know it's E0/3, so one of the nice things I like to do is open up a notepad and write some of these things down, especially when you get started, because it'll help you out a lot to remember what you did, basically. So you think of an IP address. Most home routers come with 192.168.something. In this case, it's a /24. This mask, of course, would be 255.255.255.0 because each of these octets is 8 bits. So when you do the CIDR or classless interdomain routing notation, it's how many bits you're actually going to use. 255.255.255.0. In this case, we only have 3 devices that need to communicate on this particular network. So when we think about 255, it's technically 256 possible combinations of addressing. You can't use 255 and you can't use 0 unless it's a /31 or /32. So if we count down from there, 256, 128, 64, 32, 16, 8, 4, 2, 1, you got to ask yourself, well, how many IP addresses do we need? Well, for VPLS, we need 3. Now, technically, 4 you would think would work. You have to remember, we're dealing with the broadcast and network, you cannot use those, which is basically the first address and the last address. So in the case of 4, it would be 0, which you can't use, 1 and 2, and then 3, which you can't use. So technically, with the 4, you only have 2 addresses, you can't use that, so you have to go to the 8. 8 allows us to use 3, 4, 5, and 6, because of course 7 is the broadcast. 8, because that's the bit you're landing on, it'll create a new network and they won't be able to talk to one another unless there's routing in between. So in this case, you want to add up these values. 128 plus 64 is 192. Plus 32 is 224. Plus 16 is 240. And plus 8 is 248. So this is going to be our mask in the 4th octet because that's the octet we're going to be using. Interface E0/3. We're going to have an IP address of 192.168.0.1. Remember, because that's the first octet. So we'll do interface Ethernet 0/3 IP address 192.168.0.1, and it will be 255.255.255. Now keep in mind, all of these ones are technically different networks. You can't get to those networks unless you route to those networks. We don't want to route to these networks. We want to stay on layer 2, so we have to figure out the network range that these are going to be on. In this case, it's 248. Now, 256 minus 248, of course, equals 8. So there's going to be 8 possible IP addresses on this network, minus 2, which is 6. 255, 255, 255, 248. Remember, you take that last octet there, subtract it from 256, and that's where you have your new network address. So 0, 8, 16, 24, 32, 40, 48, etc. These are all new networks on various LAN segments. Do show run interface E0/3. So what we can do is we can copy this out. And we're going to have 1, 2, and 3. Router 2 will be 2. And then router 3 will, of course, be 3. Once this is done, you get your systems back to the end. You want to make sure to save your config always. You want to do a show IP ARP, which is a nice thing to tell you the IP address, the MAC address, which will come in handy when we're talking about the layer 2 switching. So let's ping 192.168.0.7, which is the broadcast address. Now this only works on Cisco devices and maybe Juniper and other network devices. You can't really do this on Windows, it just doesn't want to work. But once we ping that broadcast, we should see replies to the request. in this case, we lost the first ping because that's the ARP request. We need to know the MAC address, layer 2, to get to layer 3. So you'll see here, reply to request 1 from 0.2 and reply to request 1 from 0.3. So now you're going to notice Control-Shift-6X usually cancels this out. Show IP ARP. Now we have the IP address to MAC address conversion for these interfaces. Let's see. BIA. So show interface E0/3. We're going to include BIA. Show interface E0/3. We're going to include BIA. Show interface E0/3. Include BIA. Show IP ARP. So now you're going to see here 1130 is local. 2130 is 0.2. And 3130 is, of course, 0.3. Show IP interface brief, exclude things like unassigned and not C, will show us the IP address configured on our system, and we'll leave out things like as unassigned and not connected. Show IP interface brief. In this case, not connected has to do more with switching than it does routing or router. So 3 and 2 and 1. This is a simple introduction into routing here. We see we have our devices that can communicate between one another. I don't know why I did 100.3. It's probably one of the other addresses I used. Anyway, 0.3 and 0.2. And you see they are indeed reachable. Now, what if we had an interface such as a loopback 0? In this loopback 0, we're going to have an IP address of 192.168.0.5. It's going to have a /32 mask, which basically means this is a host route. In this case, we can't use it because it overlaps. So let's try 8. So, show IP route. You're going to see here that we know how to get to the 0 network with the /29. Now once again, 8, 16, 24. How many bits? 1, 2, 3, 4, 5. So we used 5 bits for the network address. So 24 plus 5 equals 29. That's how we get the /29 setter notation within our networking. Anyway, so if we wanted these devices, R2 and R3, to be able to talk to one another, how would we do that? Well, one of the simplest methods, I know a lot of people will hate me for this, but I don't care, is using RIP. We can specify version 2 and a network. Now, this is a classful routing protocol, so you don't really have the ability to choose which interfaces or which networks you want. Like in link state OSPF, you actually have to tell the interface to basically include itself in the OSPF process. ERGRP, you can tell all of the networks in those links that are going to be advertising. So let's do the same thing down here. Router RIP, network 192.168.0.0, config T, router RIP, network 192.168.0.0. Once we do this, RIP should come up. So show IP route. Now we're not going to see any RIP routes on this guy because we haven't advertised anything from 2 or 3. But if we do show IP route from RIP, we should be seeing something. So let's try show IP protocols. You'll see here that we have routing protocol RIP running. It's sending version 1, but it's receiving 1 and 2. So technically, I should be getting information from the gateway. So routing information source 10 is showing as a routing information source. Show IP protocols. And this is the same thing. So we're routing for 0. We have a source of 1, show IP route RIP. Let's try it again. And you're going to see here I have the 192.168.0.8/32. If we do show IP route on R3, you're also going to notice it is here as well, annotated, of course, by the RIP. So if we were to ping 192.168.0.8 from 2 and 3, you're going to notice that it works. The reason it works is because, well, there's a lot of reasons to it, but going kind of outside the scope of what you're looking at. Basically, the longest matched subnet mask or CIDR is always used over a least like a less amount of bits. Yeah. That's how we can kind of do the subnetting, of course. They call it subnetting because it's less than the classful ranges. Class A, Class B, Class C, of course, 10.0.0.0, B's 172.16 through 172.31.255.255. And of course, Class C is 192.168.0.0 through 192.168.255.255. So even though Class C is a /24 from the reading you may do, it's technically a /16 when it comes to what you can configure on a local area network. Now, yes, of course, it's a /24 in Cisco. When I did a 00 in RIP, that was the classful range. I could do a 1.0 and it would still be classful. But in this case, that's pretty much as simple as that is. So, networking from layer 3 perspective is pretty much just this. You take network devices and local area networks, you provide gateways and routing between systems, pardon me, in order to allow them to communicate between one another. So say you had a server VLAN and a desktop VLAN. You'd want to have those on 2 separate IP networks. So you might have your server network on 192.168.0.0/24 and your desktop network on 192.168.1.0/24. Now, because you have those bits, 192.168.0.0 and 192.168.1.0, a /24 is the 24 bits, which tells you that all bits in octets 1, 2, and 3 here, anytime they change, they'll be in a new network. But the same thing goes for what we saw before with our subnetting. Because you see here in the 4th octet, it's changed, it's 248. Every 8 numbers in that octet equals a new network. It's 8, of course. So 256 minus 255 is 1. So every other IP address is going to be a new network that needs to be routed. Now, I know this was a little flummy and slowly subscribed here, but hopefully this gets the point across to kind of an introduction to IP addressing and RIP routing, of course. Keep in mind to look at all of our other videos, and I'm going to kind of be going through a whole CCNA bootcamp type of thing, or video training series, and I'm going to move on to probably CCNP Enterprise. I'm not sure if I'm going to be doing security or data center anytime soon because they require a lot of the software and technologies I don't have. So hopefully at some point I can grow the channel and get some of those software and hardware technologies so I can show you guys. So thanks so much, and see you in the next one.